Okay, so let's start this track already. Grüß die Damen. Good evening, ladies and gentlemen. My name is Mark Struberg, and I'm from Vienna, working at the University Vienna, Technical University, Research Center for Industrial Software. And I'm a Apache Software Foundation member. I'm one of the guys who wrote the CDI spec, currently writing the CDI spec. And I'm also one of the co-authors of Apache Open Web Beans, which is one of the CDI containers. So I know a little bit about this stuff. What are we doing today? I'd like to give you a detailed look into CDI, JSR-299, not only from a user perspective, but also from a perspective of the container itself. So I'd like to explain a few of the tricks we do internally. It's like a little bit of the magician who shows his tricks. Yeah? If you see some magician doing stuff, you don't know what is happening, but it looks funny. And most of the users I've seen, they just use techniques and don't understand really what's going on inside those stuff. So they copy and paste slides from Stack Overflow and so on, and it works, but they don't really know what's happening inside and how this really works. And the thing is that with each design decision you make, you will get good things and bad things. That's the basic of all design decisions we do. And each of those containers, also GPA and stuff, is full of such design decisions which might work well in most situations, and in some situations have a serious drawback. And I'd like to give you an overview about this stuff we use here in the JSR-299 containers, about the little tricks. So if you hit a real problem the next time, you might think about it a bit, and then you maybe can give you the answer yourself. Okay, let's look at a few basic CDI context, about a few features CDI provides for the user, and then let's dig into the details of this stuff. At the end of the session, I also like to give you an outlook about CDI 1.1, which is expected end of the year, I think. Okay, what is JSR-299? The spec is called Context and Dependency Injection for Java Enterprise. Well, this Java Enterprise at the end of this spec title is gone. It was politically motivated, and back in the 2007 year, there was a huge political debate about this. There was still the Spring versus Java EE war, and they really were catchy about this. This must be Java Enterprise and nothing else. In the reality, it's much, much more in the meantime. They also recognized that CDI is really, really useful even outside of EE environments in SE, Java SE. So you can use Apache Open Web Beans and JBoss Weld in Java SE environments. Perfectly fine today. So it's not bound to Java EE anymore. Each container, each JSR-299 container is also a JSR-330 container at inject, which Spring also is based upon. So the at inject annotation comes from this JSR-330, and each CDI container is also a fully specified TCK tested JSR-330 container. Okay, let's look at the core features. What makes CDI so unique? The major point is type safety. We don't pick up our classes, our beans by names anymore. We do it in a type-safe way. We pick our mail service and let us inject our mail service. This, the Java compiler can check these types, and if we do something wrong, then we don't hit this at runtime anymore. Like if we let us a named bean injecting, then if you mistype the name, you will hit this at runtime. Instead, CDI is based on type safety, and the compiler will catch this. Okay, the next strong feature is interceptors. CDI provides a way to portably write your own interceptors. This will run on every CDI container, on every Java EE6 container and stuff. Yeah, it's a neat feature. Events is also a pretty heavy feature, and we go into details of those features later in the talk. And the next strong point is this service provider interface for extending the CDI container heavily. You can do all the stuff you can do with annotations, can also be done programmatically via CDI extensions. And there is also unified expression language support out of the box. Okay, we have a few CDI implementations already. JBoss-Weld is the reference implementation. Apache Open Weapons, this is the project I'm working on, is used in WebSphere, for example, despite using a pretty old Open Weapons version. And Raising Candy from the Coucho guys. And I don't guess the Spring Container Core will support CDI so quickly, but there are a few Spring projects like Spring Data who also provide data bindings or bindings to CDI already. So let's take at the basic CDI contexts. If I'm going too quickly through this stuff, then please stop me. Yeah. So what is dependency injection? Most people use it, but basically all what we have is a factory pattern. It's still the same old stuff we did in the late 80s and early 90s. Back then, we created our own factory methods to create beans and don't have to write something like that in our code anymore, but to let the container or the factory method give us this mail service. So we don't create the beans, the instances ourselves, but we let the factories create this stuff. This is called the Hollywood principle, don't call us, we call you. Well, and this is also basically the Spring is working on the same idea, etc., etc. But all the magic in the dependency injection containers is still the same like the old factory pattern we used to have in the 90s. Why do we do this? Well, if we have here a very special mail service, we need an implementation. To compile this stuff, we need the implementation. If we move this to a factory, we don't need to know the implementation. We just say mail service and give me a mail service. And we don't care about the specific type. The factory knows about this, but we don't care. So it's pretty easy to change those implementations because you only have to change the factory for you. And then your code is unchanged. It's completely decoupled. And this really encourages separation of concerns. It also cleans up the dependency path. It's now really possible to work against interfaces because you don't need the implementations anymore. And in our big project, we have a layer which is full of the interfaces, which are compile time dependent in Maven, and the implementations are only runtime dependent. So no one can really grab some internal data from our implementations because it's forbidden by the compiler. Okay, what can I inject in my container? Well, every pocho, every bean or every class which has a few getters and setters, which is not final, and there is only one restriction: it needs a non-private constructor. This is not a restriction of CDI itself. This is a restriction by the proxying, and other frameworks have this restriction as well. So you can inject any HEB and other stuff. JNDI resources, data sources, all the stuff you have in JSR-250 are working also in commons annotation, is also working in CDI beans. Also post-construct, pre-destroy, and all this stuff is working in CDI beans out of the box. Good. To give you an overview, who has already worked with CDI? Okay, that's pretty. Who has worked with Spring and no Spring? Yeah, so the rest. Okay, small example. The first thing is for having the CDI container pick up our classes, we need this meta-inf beans XML file. This is basically a marker file. It can be empty or contain some additional information. But it's enough if you just do a touch and create an empty meta-inf beans XML, and the container scans class loader get resources, all meta-inf beans XML, and those chars will get picked up and scanned by the container. So let's implement a simple mail service. A mail service sends mail, of course. It is application scoped, and it has a send method and sends this stuff. What we also have is a user in our web application, which is session scoped, and we give it a named annotation. The named annotation makes this, this bean available via expression language. The default name, if I don't give this named any parameter, is the camel case name of the class. So there will be a bean like with the name user available for injection into JSF or any other framework which uses EL. Okay. Let's say we would like to make a JSF application, then we need a backing bean. In our case, this is a request-scoped mail formula. Here I have this named to provide a special name, just an example. Otherwise, it would be mail formular. Okay, and the important point here is I inject my mail service, and I inject my user, and there is no new blah 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 anymore. It's get injected by the container. My action, my JSF action, send mail, uses this mail service to send my email and returns the next page. So, no magic so far, at least from the auto side. Now the JSF page, our facelet. We have the output text where we use EL to address the user name, and here we start the action in the mail form. So what's happening here? The most important part is this factory pattern. A factory method must get called by someone. Most people are not really aware about this, but there is an expression language resolver, and if you have a JSF page here, and you have this EL, and someone clicks on this button, or the view gets rendered, the EL resolver will look up the chain and ask the CDI container, do you have a bean with the name user? And the CDI container says, oh well, I have. This is exactly this bean. Okay, let's create it. Then the CDI container will create this stuff and give it back to you. And here we have then the username. Same here. It will ask for a mail form. We have the mail form here. The container will create the mail form, will scan, oh, there are other beans as well. This mail form has at injection points, so I need to create the mail service, and the user as well will fill these injection points and iterates the tree down, and if all the dependencies, the beans, the injection points are resolved, it will give it back to you. Okay? So this is the first magic, AL resolvers. Okay, the next magic thing is, many of you know the Gang of Four, I guess. Erich Gamma et al. This book was written in 1994 or so, and it's the standard of design patterns. And the design patterns are not invented by Erich Gamma, but by a guy called Ward Cunningham, who did this in 1987. And you might know this guy because he wrote another software which he used to write down design patterns he knows, and this became the first wiki. So Erich Gamma is mostly known as the inventor of the wiki. But he also invented the Agile Manifesto, as a quote of the major Agile Manifesto, extreme programming, test-driven development, and other stuff. So this guy is really cool. And he defined the singleton originally in a different way than the Gang of Four. The Gang of Four focused on the technical parts, how to really do the locking. This was in C back then with semaphores, how to create one single instance. So the definition by Ward Cunningham focused more on the overall. And the definition of Ward Cunningham was to define exactly one instance in a well-specified context. And this is really important, because if you have a singleton, what is this worth? What is this at singleton in JSR-330? It defines nothing. It's completely underspecified. You always need to say a singleton in which context. Let's assume we have an application scoped. Then we could tell it application singleton. For my application, one instance. I could say a session scoped is a session singleton, one single instance for my session. So the other way around is, if this would not be defined, would a singleton be one for my Java VM, one for my server? What happens if I start 3 different Java VMs? Well, it's completely undefined. You could even write a cluster scope where you have a shared, or a resource sharing, etc., single resource in amongst all your cluster. GTA, for example, is an example of such things. Okay, and CDI provides you with features to write your own scopes. So when I say singleton, what does this mean? It means that the first time you access, for example, a session scoped bean, it will check if you have this bean or an instance of this bean in your session. And if not, it creates it, like the old factories did. The first time requested, it will give you the one which was created formally, which is already stored in the session. So it does this only exactly one time, of course, and if the session terminates, it will throw away this stuff, properly calling the pre-destroy, etc. Okay, what built-in scopes do JSR-299 provide? Of course, application scoped. And the CDI expert group didn't think about this well enough because there is currently a discussion going on. Just to further urge the impact of this singleton stuff. It is not clearly defined yet if application scoped is meant one per web application or one per enterprise application. So if you have an ear, be aware that this might work a little bit different in different containers. If you have a shared AGP jar within a shared IRIAN class loader with a AGP jars XML, it's not defined yet if this will be one single instance per enterprise application or per web application. So we will get this fixed in CDI 1.1. Session scoped, request scoped, conversation scoped. There is a conversation scoped provided out of the box by CDI, but I'm not suggesting to use it heavily because it has a few design problems, and you can use the Kodi, Apache MyFace's Kodi conversation scoped instead, which is capable of much more features. All those scopes are normal scopes, which mean they have a really well-defined life cycle. They have a really well-defined starting and ending point. As opposed to this, there is a special scope. This one is at dependent. At dependent means that it takes the life cycle of the bean where it gets injected to. So if I have a session scoped user bean and I have a dependent helper class or helper bean and inject this helper bean into my user, then it will be managed with the user. If the user gets thrown away, the dependent bean also gets thrown away. If I inject this in an application scoped service, then it will be managed with this application scoped bean and only gets thrown away at the end of the application. Each injection of a dependent bean means creating a new contextual instance. So these dependent beans don't have an own life cycle. They share the life cycle of the bean they get injected to. I will show you a sample of this later. Okay. Yeah, one important point. If you write a bean and you don't give it a special scope, it will end up being at dependent. This also means that if you, for example, import a wrong scope, a faces bean request scoped, which is no CDI scope, it will also end up being a dependent because the bean container only checks for the CDI scopes and it doesn't know the JSF request scoped, for example. So it says it has no scope for me. It will be ending up dependent. So be prepared. CDI spec is really good, and I wrote an application which has 40,000 concurrent users and 5 million page hits per day, easily. The machine is cold. So it's really, CDI is really cool stuff. And if I'm talking about small glitches in the spec, they're really small. There's nothing problematic in there. It's really production ready. So just like to have you be aware of those small problems you might hit if you use CDI in practice. Okay, if you use IDEA or Eclipse, you might end up importing the wrong JSF request, and then it ends up depending, and then each injection point will create, or each injection will create this new instance. Will figure this pretty soon in your application. But this might be because your bean is dependent then implicitly. Okay, if you read the JSR-299 specification, which I really suggest to do, because it's well written. It's not like some other specs which are 500 pages of history stack and with cross-references and stuff. The JSR-299 specification is really well written. It's a nice Saturday evening paper. And if you read through this spec, you will hit 3 terms which are worth explaining before you read the specification. The first one is managed bean. Managed bean is not a bean in the beans 1.0 specification, which came out 1997 or so. It means a meta information for your factories. A managed bean is basically the rule set for your factories. It said that in the 90s we had factory methods. What we now have is annotations to clear the factory rules via annotations. And one managed bean is exactly one such a factory rule. In the code, if you look at the API then, there is such a bean T, extends contextual, and this is exactly one such a factory rule, a managed bean. Okay, the next term is contextual instance. A contextual instance is exactly my singleton in this scope, in the very scope, my single user in my session, my single mail formula in my request. And the contextual instance will get created exactly by this managed bean T meta information, by the factory rule. There is a create method, and this gives you such one contextual instance. Okay, contextual instances will never ever get used directly in a user application. If you inject a user into some other bean, you will not get the contextual instance. You will only get a contextual reference. This is an important decision. Basically, a contextual reference is a proxy to a contextual instance. Who knows how a proxy works internally? Okay, let's go a little bit and some glance about this. First, there are interface proxies, which are the Java lang reflect proxy. So you give them an interface and it creates an implementation of it. We can't use this because we don't only like to use interfaces like HEP2 did. We also like to use classes, POJOs. So we need to do another trick. The other trick is called class proxying. A class proxy is a dynamically created subclass. And this subclass overloads all public, protected, and packaged scope methods and generates on the class loading, on the fly, such thing. Get instance, and then delegates to the real underlying function on the real instance. Okay, so far? So, a class proxy is a subclass. If you inject a user into your mail formula and you look at the debugger, you will not have a user instance, but you might end up having a user $$ class extends user. Yeah? This is also where the weird stack traces are coming from. If you see some stack trace from any Spring, if you enable the proxies in Spring, they do the same trick. It's nothing CDI invented. Okay, obviously, it's also pretty easy to do interceptor logic in here. So because you have wrapped all the functions already of this POJO, and you can also do something before and after the method invocation. So why do we use these proxies? By default for all normal scoped beans. Means for all CDI scopes which are not dependent. There are 3 reasons. The first one, the most important, is scoping differences. Let's look at our mail service. We have a mail service, and let's assume we inject a user into this mail service. The mail service is application scoped. Now user A is clicking on his browser. It's the first ever user on the server. What will happen? Oh, the user will get created. The mail service will get created because there is no such mail service instance in the application scope yet. and then the injection point of the mail service will get filled. If I have a @inject user in this mail service, of course the user will be injected. Okay, so I have my user Tommy sitting in the browser and clicking enter. Then what will happen? The user Tommy, with username is gleich Tom, will end up in my mail service. And the second user in a parallel session, if he's clicking a second later, he will get the user Tommy because it's still in this mail service. That would happen if we would not have any proxy. But we do inject proxies instead. The proxy does exactly that. I have my mail service and I only inject a proxy into the mail service. And if I call getUsername on this proxy, it will first resolve the real contextual instance. Means it will look up the right session and picks the real user contextual instance from the right scope session, and then uses this to delegate the method. So you can inject session scoped beans into application scoped beans easily without getting into troubles. Because on the fly, the real context mapping, the proxying to the real context is done by the proxies, by our contextual references. Okay, so far, it's a pretty heavy stuff. Okay. The second nice feature why we use contextual references is we can easily serialize this stuff. Let's assume we have a view-scoped, JSR view-scoped mail formula, not a request scoped anymore, and you inject the mail service into it. The mail service is not serializable. It may hold an open connection to the mail server, for example. Even if you make the mail formula serializable and you try to serialize the mail formula, it will blow up with a serializable exception. Not serializable exception, because the mail service is not serializable. But we don't have a mail service into our mail formula, but only a proxy, because it's application scope, normal scope, we only get contextual references. And the proxy doesn't contain any data. It's a shell object. It's only an empty facade. And this facade, always all our proxies we create in CDI are serializable. Because they have their own life cycle. They always do this stuff here. So there is this is an empty subclass with no data in it. It contains no data which is not serializable. So we can just simply serialize that stuff. And on deserialization, it's the empty facade, the empty proxy, and of course it does the get instance later if you invoke it, and then it will reconnect to the right contextual instance on the fly. So, yeah. Next thing I already mentioned is interceptors and decorators are easily implementable because we already overload all the methods anyway. Okay, how does this work together? The container boots, the CDI container gets boot, the web app gets started, we have servlet initialization listener, and if the servlet starts, the CDI container will start as well. The first thing it does is it looks get resources, meta-inf beans XML, finds all jars which are CDI enabled, and will scan all classes in those jars. For each of the classes, it will scan the class, collect some meta information, collect all our managed beans meta information, and throws this into a big list in the bean manager. The bean manager is basically the synonym for our CDI container. This is the central bean manager is the central interface for interacting with the CDI container. This means at the end of the scanning process, we have a long list of bean-t, of managed beans in our CDI container, long list of factory rules. And this will get used at runtime to do all the injection and stuff. The big improvement or the big benefit for doing all this stuff upfront at the scanning is that we can check for inconsistencies. We can check if, for example, session scoped bean, which all things getting stored in the session must be serializable by the Java servlet spec. So we can scan if all session scoped beans are really serializable. If not, the container will report this at startup. We fail early. And there are lots of validations done by the container at scanning time, at boot time. The second argument for doing this is we are much quicker at runtime because we have all the factory information already prepared. So, okay, let's do some hacking. This is just a slide. So you can later, if you grab the slides, do your own quick project setup. Good. I've told you all CDI is all about type-safe dependency injection. If you have two instances, or you need two instances, for example, a secured mail service and a normal mail service of the same type, both are mail service, then you can, in Spring, you just use the name secured, but this was not type safe. If you mistype the name and have a character too much, then it will just blow up, not finding the bean. So what we do here is we write own annotations as qualifiers. You can inject your @red car or your @blue car. You can do this type safe via these qualifiers. So this is kind of giving a flagging in a type safe way. So what are the built-in qualifiers? At named, you already seen this. This also has a special meaning. This is actually the only special qualifier. It also tells the container to give an expression language name. At default is always used if no other qualifier is especially annotated to your bean. And any is nice if you like observe events, for example. We will look at this later, and you like to observe any event. Okay, a small sample of how to get used, how to use this. I used to write an Napster Mobile, and we have some tracks in our music store, and we have a favorite track and a recommended track to view on the front screen. So we just create annotations for those, and then I can easily distinguish between those two in my code. And it's pretty easy to write those annotations. Writing annotations will be your bread and butter in Java EE6. So just add interface marks this is an annotation, give it a name. Target means on which Java field, method, parameter, etc. it can be applied. And retention runtime means it is also available at runtime and not only at compile time like deprecated and stuff. It qualifies a meta annotation and says this is a qualifier. This qualifier annotation is of JSR-299. Okay. The next cool feature of CDI are producer methods. If you don't, if there is no way to describe your factory pattern, your managed bean with annotations, you can also provide an own method to create your beans. A producer method will get invoked when the contextual instance gets created by the container. So you can write this like it produces and the type and some method name. And the return type is, of course, the type you have over. Then you can give qualifiers, scopes, etc. And each time a new favorite track is needed, this method would get called. And there is also a nice way to throw this away in a clean way. And this is the disposes method. To show an example of how this is used in production is a sample. We use this to, where am I? Oh, I'm in the wrong project. Sorry. Finding the mouse is hard. Okay, just quickly opening another project. Yeah. Where is it? Okay, we used to do this for the entity matches, for example. Ah, yeah, here it is. So move this over and maximize it. So, oops. Hard to type. Oh, here I have it. This is a perfect sample for what? Let's make this bigger. Okay. So there is this sample is from a real application, and we have a few things here. First, injection of EE things. Second, creating an entity manager. This is a producer method. This is request scoped and produces a request scoped course entity manager. This is a qualifier. We have 12 different databases. Each web app has its own database. And to distinguish those databases, we have qualifiers, course, curriculum, etc. To distinguish those. At the injection point, I can inject my course entity manager, my curriculum entity manager, etc. What's happening here is, this is request scope. So for each request, the first time invoke some service method, which is a transactional, etc., and request an entity manager. This entity manager will get created and returned by this producer method. At the end of the request, this is request scoped, the entity manager will properly be destroyed. I'm disposing the course entity manager again, and I'm doing a clean entity manager close. So this is really productive code, and it's pretty easy to define your entity manager per request pattern that way. This works really, really nice. Yeah, I think it's also pretty readable if you are used to this style of code. Okay. You mean to just write a persistence context and use it? Well, then you don't have the disposal functionality. That's a problem here. You can use producers also on the field as per CDI 1.1. This is called producer field. You don't need to write the method. You can also use a producer field. But in the CDI 1.nil spec, it's not allowed to have disposers for producer fields, but only for producer methods. We fixed this in CDI 1.1. But expect CDI 1.1 containers, well, it is already doing a beta, but to hit the mainstream, it will take another year or so. Okay. Oops. Okay, here we go. Specializes, another nice feature. How long do we? Until 30? 25 minutes, 20 minutes. Okay, specializes is used to replace the factory information, the bean of a parent class. Yeah, there is a similar annotation which is alternative. The specializes is meant for exchanging superclasses, or deprecating superclasses and exchanging the information instead. And alternatives is meant for exchanging interface implementations. We use the alternative, for example, we have a mail service, and we don't, oh, here I have it, okay. We have a mail service, and if I'm doing unit tests or developing local, I don't like to have my mail service firing 4,000 mails to the mailbox, to our server. So I'm replacing this productive mail service with a mock mail service as alternative. So everywhere where I inject a mail service and this alternative is activated in the beans XML, the mock mail service will get used instead. So there is a nice feature with the CDI extensions. I think Gerhard is doing a session, Gerhard Petacek is doing a session tomorrow about CDI extensions and a workshop on Wednesday. Where in Kodi we created another extension which has an add product stage activated, and you know the JSF product stages, production, development, etc. And we wrote an extension to automatically disable beans based on the project stage. So in our code, it is at project stage activated, development, unit test with the alternative. So this beans, this mock service automatically gets used if the project stage development or unit test is detected. So I don't need to change anything else. This just works based on the project stage. On production, it will switch to the real mail service. And I don't need to change anything else. And this is easily doable by writing own CDI extensions in comparison to the alternative at specializes. Okay, the next thing is stereotypes. You can have interceptors, decorators, and lots of annotations, and you might combine those things. Some people of you recognize this from Spring, which is something similar. I can say a stereotype is consisted of application scope, transactional, and secured. And I just like to use at service for this combination. So all my backend services are just annotated with at service instead of doing all those annotations. So in CDI 1.1, we might probably add this feature, oops, here it is, that we add an overrides attribute where you can, for example, propagate parameters of the stereotype to some other annotations. Yeah? So you can have your own stereotypes and propagating information to the meta annotations. Okay, a strong, nice little feature of CDI is interceptors. In Kodi we made a transactional interceptor, so we don't need EGBs anymore. You can do all this stuff yourself. And I will give you a little outlook about how this looks like doing an own interceptor. Okay, quick intro. We have the example transactional, and we need an annotation for this transactional, so we defined an interceptor binding. Interceptor binding says this annotation is an interceptor annotation, and we provide the implementation as well. Interceptor, special JSR CDI keyword, my own interceptor annotation, and then the only thing I need is just some random method name. The only important thing is it must return object, and the parameter is invocation context, and it throws an exception. And I can say it's in the round invoke interceptor. So every time I hit a bean, which is annotated at transactional, this code gets invoked. Zack, parareflection comes here. This is done in our proxies. The proxy will invoke the interceptor, which I configured. In our transactional interceptor, it will check if there is an open transaction. If not, then it starts one. Here is the context proceed. Here it goes further in our service layer with now an open transaction. Catch exception, rollback, and finally we do the commit. So this stuff is how EGB works internally. And you can provide this yourself. You can just type this and hack your own transactional interceptor. There is also a nice transactional interceptor in Apache MyFaces Kodi already. Okay, to enable interceptors, you have to write it in the beans XML. Good. I'd like to show you another little interceptor to give you a bit of feeling about the power of this stuff. Here I have a little small console. And what you see here are some service calls and the number, how often they get invoked, and the times they took. And if I hit my browser here and click here, then you see this logging. And actually, this stuff here is done via an interceptor. And we'll go quickly through the code showing how the interceptor look like, so you get a real example. And you can also download this example if you like to play with this stuff. Okay, here we go. The stuff I do here, the magic, is split in two parts. The first is the interceptor. The first we need is, wait a moment, invocation monitored. This is the interceptor annotation. As you see here, let's make this a bit bigger. As you see here, it's interceptor binding and the standard annotation, invocation monitored. Okay. And the interceptor is pretty small itself. This is an interceptor. Wait, let's do it a bit bigger again. And I like to show this because it has a few nice little tricks in it, which shows the power of CDI in a small example. Here we have the interceptor. This interceptor is for invocation monitored. And it has a track, a round invoke, invocation context, and it says just system nano timer start, does the call to the real function and ends the timer, and then just does a counting. And the counting is done via request invocation counter, which I inject. The request invocation counter itself is a simple request scoped bean, which just tracks in a few maps the usage. Okay, clear so far? So the nice little trick here is the following. I use the JSR-250 pre-destroy annotation. This is request scoped, so this bean will get thrown away at the end of the request. So I have collected all my invocation counts during the request, and at the end of the request, this pre-destroy method gets invoked. And what I'm doing here is to fire a CDI event. This is the CDI internal eventing system, where I just give as payload the numbers I collected during the request. And this event gets observed in a result logger. This is at observes and my type. It's again type-safe eventing. And it just prints out the results to the log. That's it. So interceptors are pretty easy. Events are pretty easy as well. Observer-observable pattern. So what else do we do with this eventing? For example, we have a menu, and this menu should change if a user logs in, should change if the user changes his language, his roles, if he picks up some replacement roles, etc. So what most applications do is they just grab the menu from the database each time, because it's impossible to cache it, this information, because everywhere in the application the credentials could change, etc. There would be lots of places where you need to think about that the menu could have changed. With the CDI events, we have a nice little mechanism to still be able to cache all those menu items. Here in our application, where do I have it? Here. Oops. If I click here on English, then it changes. If I log in, it changes, of course. So we don't reload this from database each time. What we do is we use the CDI eventing mechanism. Each time a user logs in, changes his language, changes some credentials, it fires a credential changed event. And everyone in the system is free to observe this credential changed event, and our menu bean does the same. Our menu bean is session scoped, so we don't need to change anything. We don't need to go to the database, trashing the database with every request, rebuilding the menu tree. We just do this once, and then storing it in the database. But we observe the user settings changed event, this is called in our application, and if the user changes some settings, we go and reload our menu. So we catch up the new situation, the new roles, etc. This is one of the nice things where you can use CDI, CDI events. The events itself are not scoped. No, they are delivered to all active scopes. So if you, for example, we had this problem once, if you, for example, fire a CDI event in a servlet filter, then you cannot observe it in JSF view scoped beans, because this is outside of the JSF lifecycle. There is no view map, no view built, so there are no view scope beans. But that's the only thing. All active beans in the current slice will get notified. There's also an important decision. CDI events are not JMS messages. They are not transactional and they just get fired. You can think about it like, oops, wrong slide already. You can think about it like a method invocation where you don't know which instances get invoked. So you fire the event, user settings changed, and all the registered observers will get called. And at the end, after each other. So you can pass payload, for example, which does some registering. And after the last observer gets invoked, you come back. And then your code runs further. So it's like a method call, a synchronous method call, but you don't know whom you're invoking. That's the best thing you see this from a high level. Okay, I quickly showed you some extension and what are CDI extensions? Well, CDI extensions are a nice way to interact with the container. You can do all things you can do with annotations, can be done in a CDI extension as well. You can dynamically rewrite annotations, etc. What we did, for example, in Kodi, we provided an extension who automatically rewrites JavaX faces bean scopes to corresponding CDI scopes. I told you in the beginning that if you pick you import by error the wrong JSF scope into a CDI application, it would get picked up as dependent. With our Kodi extension, this can't happen because we automatically rewrite JSF scopes to CDI scopes in such an extension. So you can do really lots of stuff. Okay, how gets the extension picked up? It's based on the Java util service loader mechanism. And you just have a meta in services. Wait, I think I have it here. Nope, I've moved this to another slide. Meta in services, the extension interface name, and you write your implementation into it. Again, I have a sample. Let's look at the second part of, where is it? Yeah, here. We have, I need to find my mouse. The interdin. So, meta in services, JavaX Enterprise Inject SPI extension. And here is the name of my implementation. Now let's look at this implementation. This extension implements extension, of course. Otherwise, it couldn't be picked up by the service loader pattern. And it interacts with the container via events, via CDI events. The only important difference is that those CDI events are really specified well. Before the container boots up, it sends a message here. I've registered all extensions. Would you like to do something? Here you can add new scopes, new qualifiers, new annotations dynamically. What we do here in this extension is, I've showed you the invocation monitored interceptor. Of course, we don't like to annotate all our classes with invocation monitored. We like to do this dynamically. Just write the configuration file. All my service impl star classes should get annotated dynamically with invocation monitored. And this extension does exactly that. We can skip the init code. And here is the important part. We have here, it observes process annotated type. This is one of such a CDI extension system event, and which will get fired after each class gets scanned. At the beginning, the container boots up, scans all jars. each class in the jars, and after he picked up all the meta info or all the annotations, it repackages into an annotated type, all this meta information, and sends such a system event. And all extensions can observe this process annotated type event and look if they like to do something. In our case, I say if my bean class matches my regapps which I've set, then I change this and dynamically, I get the annotations, and dynamically add an interceptor binding, which I defined in this rule. So I really can change, dynamically can change annotations on my class meta information. And from this point on, all the further processing will assume that there is this new annotation on the class. Okay, so that's it. The result you've seen already. There is no further stuff in there. It just says a configuration, my extension, which automatically puts this annotation onto my classes I configured, and that's it. There are a few extension projects which are pretty popular. The one is Apache MyFaces Kodi. The next one is JBoss Seam 3. It's a successor of Seam 2, but it's not binary compatible, and you have to rewrite lots of parts of your application. CDI source is a nice extension project as well. It makes a bridge or provides a bridge between Spring and CDI world. So the idea is to start a CDI container, start a Spring container, and via a CDI extension registers the Spring beans in CDI fully dynamically. So it interacts or interlocks the Spring container and the CDI container, and you can easily inject Spring beans into CDI beans and the other way around, just via CDI extension. So this shows well how powerful those CDI extensions are in practice. So, and the SIM guys, the CDI source guys, and we from Apache decided to join forces, and we started the Apache Delta Spike project in November last year. And all the new hot stuff is going on here. Delta Spike will be, we just shipped the 0.2 version, and there is a lot of traffic on the list, and we're pacing forward pretty heavily. Okay, what do we expect in CDI 1.1? Well, not that much, actually. CDI 1.0 was really stable. There are just a few clarifications, and most of the clarifications can be done without even changing the API. So if you take the latest Weld version or the latest OpenWebBeans version, there's a good chance that those clarifications, which went into CDI 1.1 until now, are already implemented. These are just clarifications like it's allowed to have a disposal also for producer fields. I don't need to change any API for that. I just like to clarify it in the spec, and that's it. Yeah? So this is fully working already in most CDI containers. There are only a few things we need to change, which are not API, which requires us to change something in the CDI API, but those are not that many features actually. The main thing is to clarify enterprise application scope versus web application scope. And with enterprise application scope, you hit a lot of problems which are also not yet clarified and specified in HEP. That's the reason why most HEP containers still use a flat class loader hierarchy, because the spec is completely fucked up if you have class loader isolation. So, and we like to get the visibility rules done. We like to force the Java EE7 expert group to think about this really, not only as recommendation as it is today, but to really think about it and make it functional, because it's really broken at the moment. And it's not really a problem of CDI, but it's a problem of the EE7 spec or the EE6 spec. Just a problem is if you have a web application scoped specialization, an application scoped specialization in a single web app, it can't, of course, be seen from another web app if you have a proper class loader isolation in place. Yeah, and Glassfish is completely blowing up if you do this, and other containers are just acting weird. So, best bet is to use EGP for enterprise stuff, and for web applications, use CDI. Okay, new things to come. XML configuration is a nice little thing. We have lots of requests from managers, but I've talked with implementers. It's actually useless. No one uses this anymore. The people working with CDI are happy to get rid of all this XML stuff, and they will do a devil about reintroducing any XML. So this is on the CDI list. Was properly was heavily announced, but I like to really shut this up. It's not usable anymore. We don't need this. There is a seam extension, seam XML, where you can do all this stuff with XML configuration in a portable extension. So why do we need to give this to write this into the spec to add 50 more pages of configuration definition? It's just useless. You also already can have your configuration of the beans in the database, or you can even parse Spring XML and do proper CDI stuff with it. So that's it for today. Any questions? Okay, I guess I skipped this. We don't have time anymore. Any questions, or do you like to go further into the details? Further into the details? A few pitfalls. Okay, one, because you will, if you work with CDI, you will hit this after 2 hours or so. I've told you about our menu item, yeah? A menu is a tree. I have this spelling error since years here. Menu item has children, menu items. It's forming a tree, a menu tree, of course. And you can't properly create a menu item or a complete menu just by saying, okay, this is session scoped. Because it will create you a single contextual instance of this menu item, but who fills the whole menu tree? You only have the parent menu. That's not enough. So you need a service for doing this. Okay, let's make a service which fills the stuff from the database, and a producer method which says, whenever I need a menu item, I will just load all the menu tree from the database with my user credentials, filtering, etc. So a producer method which creates a session scoped menu item for me. Okay, so far? This will blow up. So where is the bug? The bug is here. A thing is, I mentioned that every bean gets picked up as @dependent bean. And the container will throw an ambitious resolution exception because he doesn't know which one to take. You have 2 beans here. Yeah? Whenever you use producer methods, you will pretty quickly hit this problem. The first is here. This is a dependent bean which resolves, which is a candidate for injection if you say @inject menu item. Perfectly well. It's a bean. Here we have a second bean which is candidate for injection for a menu item. So what can we do? We can use the typed. With typed, I can say explicitly this bean is of that types. Resolve these candidates. If I say you resolve no candidates, well, then this menu item will not be a candidate for injection for anything anymore. So the only bean for menu item which remains is my producer method. So whenever you do producer methods, keep this in your back. This typed is a neat thing. The theme guys did a Adveto extension for exactly that. But this typed is coming from the CDI specification itself and is pretty handy and works well. Okay, another typed is another nice little thing to give you a feeling about how the injection stuff works. This is taken from an Napster application. Of course, it was not a CDI app, but the basic sample is here. In the 99% of all the requests are read-only requests in such a music browsing store, and only a few buy requests. So mostly we have track read-only services, which does just the read-only stuff. And the administrators can add new tracks. He has a track read-write service. Both are application scoped, and this will also blow up. So what's the problem here? it's perfectly fine to inject a track read-write service. If I inject a track read-write service, it will say, okay, this is the only one which resolves or which fills the rows and has the type of track read-write service, perfectly fine. But if I like to inject a track read-only service, I have an ambitious resolution exception. Because I have a track read-only service, explicitly, and this here is also a track read-only service. Track read-write service extends track read-only service. So what am I doing now? I can say, oh gosh, you are only a track read-write service, and then the automatically superclass pickup for the types will get disabled. But only this bean will only act as track read-write service. So nice little stuff. I've showed you this already. Types of configuration is also a neat thing. We have this done in Kodi. I don't need any properties anymore. I just make an interface which contains methods for my configuration, and then I can use alternatives, specializes, project stage activated, exclude, etc. All the various CDI mechanics to distinguish different configurations based on the project stage, based on the server property, etc. Based on JNDI. That's a neat little thing which you can do with CDI. No more config files. We use this heavily already. Okay, I think time is up. Are there any questions? And if you have some further questions, just grab me in the evening and or Gerhard and me, and we're happy to talk about this stuff. There are tons of stuff which you can do in CDI, and this is really powerful. I have 10 more slides and another slide for extension programming itself. Yeah, just observe the Delta Spike list and you will get tons of information from there. So, thanks.